Okay, so the next question is example number 17, which is basically if the coefficients of r minus 5 term and 2r minus 1 terms in the expansion of 1 plus x raised to the power 34 are equal, find r. So basically we know that the coefficients of basically r minus 5 term and 2r minus 1 term are equal. And you want to, in the expansion of 1 plus x raised to the power 34, right? You want to find r. So in the expansion of 1 plus x raised to the power 34, 1 r minus 5 term and 2r minus 1 term, you want to find these two terms first. So you know that t of r plus 1 in general is equal to n combination r, a raised to the power n minus r, b raised to the power r. And so basically t of r minus 5 is equal to basically here your r would be 1 less than this, so r minus 5 minus 1, which is equal to r minus 6. So that would be n combination r minus 6. And in this expansion, so n is equal to 34, and n is equal to 34, and so a is over here is 1, so 1 raised to the power basically 34 minus a is equal to 34 minus r plus 6 minus r plus 6, and b would be x raised to the power r minus 6, and that is the same thing as 34 combination r minus 6. This is just 1 x raised to the power r minus 6. This is t of r minus 5. Now t of 2r minus 1, is the same thing as, again, your r would be equal to 2r minus 1, 1 less than that minus 1, is equal to 2r minus 2. And so that would be 34 combination 2r minus 2, x 1 raised to any power is just 1, so we don't have to write it, x raised to the power basically 2r minus 2. That is t of 2r minus 1. Now the coefficient here is equal to basically 34 combination r minus 6. The coefficient here is 34 combination 2r minus 2. Now we are saying that these two are equal, which means that 34 combination r minus 6 is equal to 34 combination 2r minus 2. Which means that basically, okay, so now what you need to do, actually I did a whole lot of calculation here, but it turned out to be not correct. Now, what you can do here, basically, if you remember in the chapter related to combinations, there was a theorem that we saw, or actually not a theorem, but a part of a remark that we had related to the derivation of the combination formula. We said that if n combination A is equal to n combination B, if is equal to n combination B, that implies that either A is equal to B or n is equal to A plus B. That basically we proved it before, right? Which means that 34 combination r minus 6 is equal to 34 combination 2r minus 2. That implies that r minus 6 is equal to 2r minus 2, or basically n is equal to a plus b, which is 34 is equal to r minus 6 plus 2r minus 2, right? So based on this, we can say that, and of course, if we didn't have this result, it would be very complicated to calculate r over here. It wouldn't really be easy at all. Because I did try to do that, you would get into a complicated form of combination, and then you would have to calculate, and that would actually be so complicated. Okay, so if I solve this part, I will get r minus 2r is equal to negative 2 plus 6, which means that negative r is equal to, 6 minus 2 is equal to 4, which means that r is equal to negative 4. Of course, r cannot be a negative number, right? So this is not acceptable. But you can say that 34 is the same thing as r plus 2 is equal to 3r and negative 8, right? So that means that 46 by 46 thirds is equal to 34, no, right, 42 thirds. So that would be basically, if I take r to the other side, it's on positive 8, 34 plus 10 is equal to 44, so 42 is equal to 3r, and then 3 times 12 is equal to 12 times 3 is equal to 30. 42 divided by 42, what is 42 divided by 3? 42 divided by 3. My mind is not working properly right now. 3, so 4 times 3 is equal to, that's 14. R is equal to 14. So that means that R is basically equal to 14, right? Now, this is basically the value of R. Now, the next thing that we have here is a couple of exercises, miscellaneous exercises on chapter 8. There's only 10 of them, but these exercises usually take a long time, so you have to get ready for probably 2 videos, 2 hours or so. Now, question number 1, so this part is basically miscellaneous exercise. Miscellaneous exercises on chapter 8. And question number 1 is find A and B and N. Question number 1 is find A, B, and N in the expansion of A plus B raised to the power n if the first 3 terms of the expansion R 729, 7290, and 30375 respectively. Okay, so the first three terms of this expansion are basically these numbers. So what that means is that basically in the expansion of the general term of this expansion would be t of r plus 1, t of r plus 1, which is equal to n combination r, a raised to the power n minus r, b raised to the power r. Which means that t of the first term, t of 1, at t of 1 your r is equal to 0. That means that you get n combination 0. Basically we have a is the same thing as a here, so a raised to the power n minus 0, b raised to the power 0, which is the same thing as n combination 0, a raised to the power n, and that is equal to 729. T of 2 is equal to n combination 1, 2, 1, a raised to the power n minus 1, b raised to the power 1, and that is equal to that is equal to 7290. And t of 3 is equal to n combination 2, a raised to the power n minus 2, b raised to the power 2, and that is equal to 30375. So you have basically these pieces of information, n combination 0, a raised to the power n. That means that basically I can write a raised to the power n as, for example, 729 by n combination 0, and n combination 0 is equal to 1, right? So I can write this as n a raised to the power n is equal to 729. N combination 1 is equal to n. That means that I can write this as n times a raised to the power n minus 1 times b is equal to 7290, right? And then combination 2, you cannot do much over there. So let's see. We have a raised to the power n, a raised to the power n minus 1, and n combination 2 is equal to this. N combination 2 that is equal to this. So one more thing that we can include here is that let me see. Now one thing that you can do is that you know that n combination 2 is the same thing as n factorial, n minus 2 factorial, and 2 factorial, which is the same thing as basically n 1 times 2 times 3 times all the way up to n, and n minus 1 is the previous term, n minus 2 is the previous term, and then n minus 2 factorial is 1 times 2 times 3 all the way up to n minus 2. And you have a 2 over here as well, so you can simplify all of this with all of this. So that's n times n minus 1 divided by 2. That is that. So you can say that basically n times n minus 1 times a raised to the power n minus 2 times b squared whole divided by 2 is equal to 30375, which means that basically you can multiply this out. You get n times n minus 1 times a raised to the power n minus 2 times b raised to the power 2 is equal to 2 times this is equal to basically 30375 times 2 5 times equal to 10 1 14 15 1 basically 2 times is equal to 706, so 60750. And therefore you can say that basically you can say that n times n minus 1 times a raised to the power n minus 2 times b squared is equal to 60750. That's one more thing that you can use. And if I divide now you essentially have to divide something by something else so that these hopefully cancel out. Meaning that, for example, a raised to the power n if I call this number 1, if I call this number 2, and if I call this number 3, I can say that, for example, I don't know, for example, number 2 divided by number 1, 2 divided by 1, we have basically n times a raised to the power n minus 1, a times n times a raised to the power a minus 8 times n times a raised to the power n minus 1 times b is equal to n raised to the power n minus 1 times b is equal to 7290, and that is number 2. And number 1 is a raised to the power n is 729. A raised to the power n is 729. That is number 1. So 2 divided by 1 would give you basically n a raised to the power n minus 1 times b. Divide that by a raised to the power n is equal to 7290 divided by 729. And so you would get a raised to the power n minus 1 divided by a raised to the power n is equal to a raised to the power n minus 1 minus n, which is the same thing as these two will cancel out. That's a raised to the power minus 1, a raised to the power minus 1, which is the same thing as 1 over a. So you would have an a over here. So nb divided by a is equal to, and then this side you would have a 10 and a 1, which means that nb divided by a is equal to 10. That you might be able to use somewhere. At least some ratio in this you would be able to use, right? Now if you divide, for example, this by this, 3 by 2 by 3, you will have let me make a screenshot here so that so if you divide 2 by 3, you will have divide 2 by 3, we have, so 2 is n times a raised to the power n minus 1 times b is equal to 7290. That is number 2. So I'm just going to do the division basically. So n times a raised to the power n minus 1 times b, and divide that by 3, which is n times n minus 1 times a raised to the power n minus 2 times b squared is equal to basically 7290 divided by 60750. So then you would be able to cancel n and n, b and b, a raised to the power n minus 1 divided by a raised to the power n minus 1 minus n minus 2, and that's the same thing as a raised to the power n minus 1 minus n plus 2, n minus 1, and that is 2 minus 1 is equal to 1, so that's just an a. That is just an a. And that means that, and then over here you can write 729 by 6075, 11 plus 7 is equal to 18, divide by 3, you can divide, and 60712 plus 6 is equal to 12 plus 6 is equal to 18. You can divide that by 3 as well. So 729 divided by 3, you will get 2 times 3 is equal to 6, 1, 4 times 3 is equal to 12, and 9, 3 times 3 is equal to 9. So divide by 3, you will get 243. And 6075 divided by 3, you will get 2 times 3 is equal to 6, 0, 7, 2 times 3 is equal to 6, 1, 5, and 5 times 3, so that's 2025. And then you can still probably 7 plus 2, so 243 divided by 3 is equal to 8 times 3 is equal to 24, so that's 81 divided by 3, and 225, if you divide it by 3, you will get 8 times 3 is equal to 6 times 3 is equal to 18, 222, 7 times 3 is equal to 21, and 15, 5, 675, 12 plus 12 plus 5 is equal to 17. I don't think 81 can be divided by any further by 675. Oh, that's 3 to 25. 675 can be divided by 3. 675 divided by 3 is equal to 225. 13 plus, okay, alright. Okay, so then you can say that basically 675 divided by 3 is equal to 2 times 3 is equal to 6. 2 times 3 is equal to 6, 1, 5, 5, 225. And 81 divided by 3 is equal to 27. So that's 27 by, and again 7 plus 2, 225 divided by 3. I should have prime factorized this. Divide by 3, 7 times 3 is equal to 21, 15. and 575, 75, and that's a 9, and again divide by 3, you'll get 25 and 3, so that's 3 by 25. That is 3 by 25. That is 3 by 25. So that means that basically a divided by n minus 1 times b is equal to 3 by 25. So you can see that over here you can write this as a divided by b times 1 divided by n minus 1 is equal to 3 by 25, which means that basically a divided by b is actually this divided by this, which is this times the reciprocal of this, which is 3 times n minus 1 divided by 25. That is what you get over here. And then over here we said that basically n times b divided by a, n times b divided by a is equal to 10, which means that b divided by a is equal to 10 divided by n, which means that a divided by b is equal to n divided by 10, right? So a divided by b is equal to n divided by 10. A divided by b is equal to n divided by 10. So which means that basically, so these are both a divided by b, so you can say that then 3 times n minus 1 divided by 25 is equal to n divided by 10. Divided by 5 you will get 2, divided by 5 you will get 5, and then you will get basically 3n minus 3 divided by 5 is equal to n divided by 2, and then if you cross multiply you will get 2 times 3n minus 3 is equal to 5n, and 6n minus 6 is equal to 5n, and 6n minus 5n is equal to 6, and n is equal to 6. So now if n is equal to 6, you can say that basically a divided by b, you can now solve for a and b, meaning that this equation from this you can write if n is equal to 6, this would be, so you can write a divided by b is equal to 3 times 6 minus 1 is equal to 5 divided by 25, so that you can cancel out. A divided by b is equal to 3/5, and if n is equal to 6 here, this becomes a divided by b is equal to 6 divided by 10, which is basically divided by 2, 3 divided by 2, 5, 3/5. The same thing. Okay. Now, if a divided by b is 3/5, well, at least we can at least have that. So here we have basically a divided by b is equal to 3/5, right? So what that means is that we can probably somewhere over here somewhere over here do something so that if I put n is equal to 6 here, for example, that gives me a, right? So that means that a raised to the power, here we have a raised to the power n. Here we have a raised to the power n is equal to 729. Now a raised to the power 6 is equal to 729. So the only thing that we need to do is just prime factorize 729 and see what we get, right? So I'm going to create a new layer here, and we have a raised to the power 6 is equal to 729. A raised to the power 6 is equal to 729. So what you can do is that you can prime factor. Of course, you can write this. You can write a as the 6th root of 729. But this is essentially easy. 729 divided by basically 11 plus is divided by 3. Divide by 3, you will get 2 times 3 is equal to 6, 1, 12, 4 times 3 is equal to 12, and 243. So that's 3 times 243. 243, if you divide by 3, you will get basically 6, 7, 7, 8 times 3 is equal to 24, and so 1 times 3 is equal to 3 times 81, right? And that's 3 times 27, and that's 3 times 9, and that's 3 times 3. Which means that 729 is the same thing as 1, 2, 3, 4, 5, 6, 3 raised to the power 6. So a raised to the power 6 is equal to 3 raised to the power 6. Which means that basically, a is equal to 3. Now, if a is equal to 3, if a is equal to 3 here, this implies that a is equal to 3, and then, so basically we have n times, then we can use any of these equations here. For example, this one, let me see if I can make a screenshot here. Okay, n times a raised to the power n minus 1. We have n times a raised to the power n minus 1 times b, 7290, times b is equal to 7290. N a raised to the power n minus 1 times b, 7290. A is equal to 3. A is equal to 3, and n is equal to 6. So 6 times a, 3 raised to the power, 3 raised to the power, well, 6 minus 1 is equal to 5, times b is equal to 7290. So this means that basically that is 2 times 3, right? 6 is equal to 2 times 3 times 3 raised to the power 5, times b is equal to 7290. We said that basically 729 is equal to 3 raised to the power 6, right? Which means that 7290 is the same thing as 3 raised to the power 6 times 10, which is 3 raised to the power 6 times 2 times 5. Which means that, and let me check this actually, 3 raised to the power 6 is equal to 729, okay. And so I can write this as this part. I can put these two 3's together, 2 into 3 raised to the power 6 times basically b is equal to 7290. 7290, I can write it as 2 times 3 raised to the power 6 times b is equal to 729 times 10. And then this is the same thing as 729 here. So I can cancel these out and simplify this, and then that means that b is equal to 5, right? So that means that basically means that a is equal to 3 and b is equal to 5 and n is equal to 6. That is basically the answer there. Okay, so that was question number 1. Let me take a look at the solution. Okay, so the answer is actually correct. That was the correct answer. Now, question number 2 is basically find a if the coefficients of x squared and x cubed, the coefficients of x squared and x cubed in the expansion of of 3 plus 8x raised to the whole raised to the power 9 are equal. So the solution here is you want to find if the coefficients of x squared and x cubed in the expansion of this are equal. So you essentially need to find which term basically x squared appears in the expansion of 3 plus ax raised to the power 9. Also, you need to find in which term x cubed appears, and then find the coefficients of those two terms, equate them, because here we are saying that the coefficients are equal, and once you equate them you'll be able to get a, right? So, and in order to basically to find out in which terms these basically x squared and x cubed appear, you need to essentially find the general term of the expansion. So that means that t of r plus 1, which is equal to n combination r, a raised to the power n minus r, b raised to the power r. In this particular case, t of r plus 1 is equal to n, which is equal to 9 combination r. A is here 3 raised to the power 9 minus r, and b is ax raised to the power basically r, right? So that means that basically this is 9 combination r, 3 raised to the power 9 minus r, and a raised to the power r times x raised to the power r. A raised to the power r times x raised to the power r. That is t of r plus 1. That is t of r plus 1. That is the general form of the expansion of this thing. So now, if you want to know where x squared appears, so when r is equal to 2, that means that the exponent of x here is equal to 2, and then that is the term where x squared appears. So now when r is equal to 2, we have basically t of 2 plus 1 is equal to 9 combination 2, 3 raised to the power 9 minus 2 is equal to 7, a raised to the power 2, x raised to the power 2, right? And so that is equal to 9 combination 2, 3 raised to the power 7, a raised to the power, well, you don't really need to write this. You can write this as the coefficient here becomes basically, here the coefficient is Here the coefficient is equal to 9 combination 2, 3 raised to the power 7, 3 raised to the power 7, a raised to the power 2. That is the coefficient of the third term, or where x squared basically appears. Now we are looking also for the term where x cubed appears. So that means that when r is equal to 3 here, when r is equal to 3 here, when r is equal to 3, we have basically t of here 3 plus 1 is equal to t of 4 is equal to 9 combination 3 raised to the power basically 9 minus 3, which is equal to 6, a raised to the power 2, a raised to the power 2, and I'm sorry, a raised to the power 3, a raised to the power 3, and x raised to the power 3, which means that here the coefficient here is equal to basically 9 combination 3, 3 raised to the power 6, a raised to the power 3. Now we are saying that these two coefficients are equal. We are saying that these two coefficients are equal, since the two coefficients are equal, we have, so 9 combination 2, 3 raised to the power 7 times a squared is equal to 9 combination 3, 3 raised to the power 6, a raised to the power 3. So what you can do is that you can divide both sides by 9 by this side, meaning that you can say that basically 9 combination 2, 3 raised to the power 7, a raised to the power 2, divide that by 9 combination 3, 3 raised to the power 6, a raised to the power 3 is equal to 1. And then you will get an a over here, a 3 over here, and 9 combination 2 by 9 combination 3 is the same thing as 9 combination 2 by 9 combination 3 is the same thing as basically 9 factorial over 7 factorial 2 factorial 9 factorial 6 factorial 3 factorial, and that's the same thing as that's the same thing as you can write this as 7 factorial times 8 times 9, divide that by 7 factorial times 2, and this you can write it as 6 factorial times 7 times 8 times 9, divide that by 6 factorial times 6, and then you can 6 factorial, 6 factorial, 7 factorial, 7 factorial can cancel out. Now you can simplify this numerator with this numerator. The denominator you can cancel out 2 and 3, and so you have basically this is the whole, this is all 1 divided by 7, so that means that then this is 1 divided actually by 7/3. So you have a 7 over here, you have a 3 over here, 1 divided by 7/3, which is 3/7, which means that 3/7, and you have the a over here is equal to 1, which means that 7a is equal to 3 and a is equal to 3/7, which seems to be not right. Let me see. Number 2. Oh, there is a 3 over here as well, right? There's a 3 over here as well. So you can write this as 9 divided by 7. 9 divided by 7 times a is equal to 1. That means that basically 7a is equal to 9, and that means that a is equal to 9/7. That is basically the answer here. A is equal to 9/7. Okay. Question number 3, we have basically find the coefficient of x raised to the power 5 in the product using the binomial theorem. So we want to find the coefficient of x raised to the power 5 in the product basically 1 plus 2x raised to the power 6 times 1 minus x whole raised to the power 7 using the binomial theorem. Okay, so in order to do this, you want to find the coefficient of x raised to the power 5 only, and you don't really care about the other powers of x. So what I'm going to do is that I'm going to basically expand this and then multiply them together. But we will multiply only partly, meaning that only the terms that lead to x raised to the power 5. The other terms we will leave them alone. And then we will see what the coefficient is going to be. Which means that I'm going to write 1 plus 2x raised to the power 6 is the same thing as, so you know that this is n combination 0, n combination 1, and so on and so forth. Meaning that the general term, of course, you can use the other form of the binomial theorem as well, meaning that normally you would write a plus b raised to the power n is equal to n combination 0, a raised to the power n, b raised to the power, for example, 0 plus n combination 1, a raised to the power n minus 1, b raised to the power 1, plus n combination 2, for example, a raised to the power n minus 2, b raised to the power 2, plus all the way up to n combination n, a raised to the power n minus n, b raised to the power n, right? But we showed that basically 1 plus x raised to the power n is the same thing as n combination 0 plus n combination 1x plus n combination 2 times x squared plus n combination 3 times x cubed plus all the way up to n combination n x raised to the power n, right? So that means that we can use this over here, which means that I can say 6 combination 0, and basically then, and that's just a constant, plus 6 combination 1, then x, which is equal to 2x raised to the power 1, plus 6 combination 2, 2x raised to the whole raised to the power 2, plus 6 combination 3, 2x raised to the power 3, plus 6 combination 4, 2x raised to the power 4, plus 6 combination 5, 2x raised to the power 5, plus 6 combination 6 times 2x raised to the power 6. That is, of course, the whole 2x raised to the power 6. So then you can basically simplify this, of course. Okay, so now if you simplify this, you will get basically 6 combination 0 plus 2 times basically 2 times 6 combination 1 times x plus 4 times 6 combination 2, 4 times 6 combination 2 times x squared plus 8 times 6 combination 3, 6 combination 3 times x cubed plus 16 times 6 combination 4 times x raised to the power 4 plus 32 times 6 combination 5 x raised to the power 5 plus basically 2 raised to the power 6 is equal to 64, I suppose, right? So 64 times 6 combination 6 into basically x raised to the power 6. So that is basically 1 plus 2x raised to the power 6. You have 1 minus x raised to the power 7 as well. You have 1 minus x raised to the power 7 as well. So we said that 1 minus x raised to the power n is the same thing as n combination 0 minus basically n combination 1x plus n combination 2x squared minus n combination 3, for example, x cubed, plus all the way up to negative 1 raised to the power n, n combination n, x raised to the power n, right? So which means that based on this, you can say that this is equal to 7 combination 0 minus 7 combination 1, 7 combination 1 x raised to the power 1 plus 7 combination 2 x raised to the power 2 plus minus 7 combination 3 x raised to the power 3 plus 7 combination 4 x raised to the power 4 minus 7 combination 5 x raised to the power 5 plus 7 combination 6 x raised to the power 6 minus 7 combination 7. So you have positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. 7 combination 7 x raised to the power 7. And so now what were we were supposed to find the coefficient of x raised to the power 5. So over here basically, if I have basically x raised to the power 1, x raised to the power 2, x raised to the power 3 through x raised to the power 6. And I have over here x raised to the power 1 through x raised to the power 7. So that means that if I write, so the terms, so I can say the terms involving basically x raised to the power 5, involving x raised to the power 5 in the product basically 1 plus 2x raised to the power 6 times 1 minus x raised to the power 7 are as follows. So you can basically take this constant and multiply it by x raised to the power 5. So that is 6 combination 0, which is equal to 1. 6 combination 0 is equal to 1. So So I can write this as 1. So you can write 1 times, for example, x raised to the power 5 here, which is basically negative 7 combination 5, x raised to the power 5. Negative 7 combination 5, x raised to the power 5. And add to that, so you can take this term, which is basically x, and multiply it by x raised to the power 4. So which is basically, let me separate these two so that we don't make any mistakes. So we can take this term, so this is already taken care of. You can take this x and multiply it by x raised to the power 4, which would be this term over here. So you have basically 2 times 6 combination 1 times x, and multiply it by x raised to the power 4, which is 7 combination 4, x raised to the power 4. So this is already taken care of. Now we can take this term and multiply it by x raised to the power 3, which would give you 4 times 6 combination 2 times x squared, and multiply it by negative 7 combination 3. 7 combination 3. Actually, that's not negative 7, but 7 negative of 7 combination 3. Negative 7 combination 3 x raised to the power 3, right? You can write this as well. And this has to be, of course, this way, times this, right? Next, what you can do, so this is also taken care of. It's 4 times 6 combination 2x squared times negative 7 combination 3 times x cubed. So this is also taken care of. You can take this term x cubed, so you can write plus 8 times 6 combination 3 times x cubed, and multiply it by x squared. Multiplied by x squared, which would be 7 combination 2 times x squared. So this is also taken care of. 8 times 6 combination 3x cubed times this term over here. I can take this term 16 times 6 combination 4 x raised to the power 4, and multiply it by x raised to the power 3 plus 2 is equal to 5. So I can take this term over here, 6 raised to the 6, basically 16 into 6 combination 4, x raised to the power 4, and multiply it by x, which is negative 7 combination 1 times x. Right? I can do that as well. Negative 7 combination 1 times x. So this is also taken care of. And last but not least, I can take this term. So I can write plus basically 32 into 6 combination 5, x raised to the power 5, and multiply it by a constant, by any constant, which is 7 combination 0, right? That I can do as well, and all of these terms would give me basically x raised to the power 5, 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 and x raised to the power 5. And therefore we can say that so here we can say that, so you have basically 1 times this, so negative 7 combination 5. 7 combination 5 is the same thing as 7 combination 5 is the same thing as 7 factorial. 7 minus 5 is equal to 2 factorial 5 factorial, which is the same thing as 5 factorial times 6 times 7 over 5 factorial times 2. You can cancel these two out. 3 times 7 is equal to 21. So that's negative 21 x raised to the power 5. It's negative 21 x raised to the power 5. And plus, and add to that basically, so you have 6 combination 1. 6 combination 1 is the same thing as 6 combination 1 is the same thing as basically n combination 1 is equal to n, of course, right? So that's equal to 6. That is equal to 6. 2 times 6 is equal to 12. So that's 12 times x, this first part over here. And then the next part is 7 combination 4. 7 combination 4 is the same thing as 7 factorial. 7 minus 4 is equal to 3 factorial 4 factorial, which is the same thing as 4 factorial times 5 times 6 times 7. 3 factorial is equal to 6 times 4 factorial. You can cancel these two out. You get 5 times 7 is equal to 35. So that's 35x raised to the power 4. 35x raised to the power 4. So 35 times 12 is equal to 35 times 12 is equal to 2 times 1 is equal to 10. 1, 6, 7, 0. And 1 times 35 is 35. 0, 12, 1, and 420. 420. That's 420 x raised to the power 5. 420 x raised to the power 5. 12 times 35 is equal to, let me see if I didn't make any mistakes here. 35 times 12 is equal to 420. Okay. So the next basically, the next part that we have over here is basically is this part over here. So this is already taken care of. This is already taken care of. So you have 6 combination 2 times 4. What is that? 6 combination 2. 6 combination 2 is the same thing as 6 factorial, 4 factorial, 2 factorial, which is equal to 4 factorial times 5 times 6 divided by 4 factorial times 2, and cancel these two out. 3 times is equal to 15, right? So 6 combination 2 is equal to 15. 4 times 15 is equal to 60. That's 60x squared. And 7 combination 3 is the same thing as 7 combination 3 is the same thing as 7 factorial, 4 factorial, 3 factorial, which is equal to 4 factorial times 5 times 6 times 7, 4, 5, 6, 7, and 4 factorial times 6, 4, and you can cancel this, that's 35. That's negative 7 combination 3, that's negative 35 because of this negative sign, x raised to the power 3. And so you have 6 times 35 times 60 is equal to 35 times 6, negative sign times negative sign and 0. So you have 6 times 3 is equal to 180, 30 is equal to 0, and 11, 210, that's negative 200. 6 times 35 is equal to 210. I get 0, negative sign, that's negative 2100. Negative 2100 x raised to the power 5. So that's negative 2100 x raised to the power 5. Which means that basically this one is also taken care of. When it comes to this part, 6 combination 3 is equal to 6 factorial 3 factorial 3 factorial, which is equal to 3 factorial times 4 times 5 times 6 over 3 factorial times 6 and 6, 3 and 3 factorial, that's equal to 20. And over here 6 combination 3, 7 combination 2 is equal to 7 factorial 5 factorial 2 factorial, which is equal to 5 factorial times 6 times 7, 5 factorial times 2 3, that's equal to 21. So that is 8 times 20, which is equal to 160 x cubed, and 7 combination 2 is 21 x squared, and if you multiply them you will get 16 times 21 is equal to, you have 0 there, 16 0 12 1 320, so you have 6 3 and 3 3 3 6 0, so you'll get 3 3 6 0 3 3 6 0 x raised to the power 5. So that is positive, that is plus 3 3 6 0 x raised to the power 5. Which means that this part is also taken care of. And so you have basically 6 combination 4, 7 combination 1. This is equal to 7. There is no problem with this, but this part 6 combination 4, 6 combination 4 is the same thing as 6 factorial 2 factorial 4 factorial, which is equal to 4 factorial times 5 times 6 times 6, 4 factorial times 2, cancel these two out, 3 times 5 is equal to 15. Now 15 times 16 is equal to basically 30. 35 times 1 is equal to 80, 0, 16, so 0, 8 plus 6 is equal to 14, 1, 240, so you have 240 x raised to the power 4 times negative 7x. Now, then what you will have is 224 times 7, negative sign 0, 7 times 4 is equal to 28, 2, 14 and 16, 0 negative sign, that's negative 1680 x raised to the power 5. That's negative 1680 x raised to the power 5. Right, so that is that part. This is basically this part. And then over here you have 7 combination 0, which is equal to 1. And then you have 32 times 6 combination 5. Now 6 combination 5 is the same thing as 6 factorial, 1 factorial, 5 factorial, 1 factorial and 5 factorial, which is the same thing as 5 factorial times 6 divided by 5 factorial, which is equal to 6. and 6 times 32 is equal to 12, 1, 1892. That's 192 x raised to the power 5, right? That's plus 192 x raised to the power 5. And therefore you have basically all of these terms. Now you have to add together the negative terms, meaning that you have 2100 and then 1680 and basically 1680 and 21. So you'll get a 1 over here. 2 plus 8 is equal to 10. So 1, 6 plus 2 is equal to 8. 3801. 3801. So that's negative. This number is negative. And then you have all of these positive numbers, 420 and 3360 and 192. Add them together, you'll get a 2. You'll get a 15, 17, 1, and 7 plus 2 is equal to 9, 3972. That's positive. So 3972 minus 3801 is equal to 2 minus 1 is equal to 1, 7, 1, and 0, 171. That is equal to 171 x raised to the power 5. Which means that the coefficient of x raised to the power 5 in the expansion, in this expansion here, in this product, is actually equal to 171. That's the coefficient. That is question number 3. 171 is the correct answer. Okay. We have a couple more questions here. I'll end this video here and then we will continue in the next video. Thank you.